Okay, welcome everybody. This is 4.1, Systems of Linear Equations in Two Variables. So we will be solving a system of linear equations. There are multiple ways to solve a system of linear equations. One is to graph it. Two is to use substitution method. Three is to use elimination method. And four is to use matrices. So there are many ways to solve a system. Today, we are just going to focus on substitution and elimination. Okay, I don't think I need these. Perfect. So let's start on the definition of a system of linear equations. It consists of two or more linear equations. An ordered pair, x, y, is a solution of the system of linear equations. And this is true if it satisfies each equation. So we have our first example here that is solved for us already. So we see that the two lines are intersecting. So we see that our two lines intersect. So the exact point where these two lines intersect, where these two functions intersect, or even better, where these two linear equations intersect, happens to be the unique solution that satisfies both equations. So that is what we're going to do today. We're going to look for that unique solution by two methods, substitution and elimination. And of course, in order for them to have a solution, the lines must intersect. If they don't intersect, we don't have a solution, as seen in the pictures below. So a consistent system has at least one solution. The picture on the left is a consistent system. The lines intersect, and at that intersection is the unique solution, which means it is a consistent system. You have an inconsistent system, which has no solution, which means your lines do not intersect, which is represented by the second picture. We have parallel lines. They do not intersect. There is no solution. It is inconsistent. And then the third one, you have a dependent equation. You have a consistent system where the equations are dependent, basically meaning the equations are the same. So what we have are two lines on top of each other, which means they are intersecting at every single point infinitely, meaning they have infinitely many solutions. This is also a consistent system, but there are infinitely many solutions for this one. Okay. So again, down there it says we want to focus on substitution and elimination. All right. Here are some steps to help you with substitution method. So for substitution method, the key is to substitute some term in for a specific variable. So we have to make a decision. Do you want to substitute in terms of x, or do you want to substitute in terms of y? It does not matter as long as we do it correctly. So what happens is that, let's say we substitute an equation in for x. This means that we rearrange the first equation for x, which means we're going to plug it into the second equation for x. Or you can rearrange the second equation for x and plug it into the first equation for the variable of x. And the same can be said for y. There is no wrong choice. There can only be mistakes. Mistakes can be made, but there is no wrong choice in choosing what you want to substitute. So let's go ahead and try the substitution method. So, how much space do I have? Okay. So for example 1, we're given the system of equations, x minus 4y equals negative 17, and 3x plus y equal to 1. Okay, so do you want to make a substitution for equation 1? Or do you want to make a substitution for equation 2? And again, here is where we have the most power in math. We get to choose what we want. And how do you make the easy choice? Well, you look for the easiest looking equation. And that kind of happens to be both of them. So now it's just basically based on your choice, whatever you're feeling. So if I look at equation 1, I'm going to say, let's go ahead and solve this equation for x, meaning let's make a substitution for x. So I'm going to choose equation 1. All right. So I'm going to make this in steps as well. So step number 1. Rewrite equation 1 in terms of x. I'm sure I could word that smaller, who knows. But what we're going to do is just solve equation 1 for x. So I'm going to write it here. X minus 4y equals negative 17. To solve for x, all I have to do is add 4y to the right side, which means I'll get x equals 4y minus 17. Now, what we have just created is a substitution. X now contains all this information. X is now equal to 4y minus 17. So, what we're going to do with this information, first off, I'm going to label it. This is going to be our substitution. Now, since we rearranged equation 1, we must plug equation 1 into equation 2. So we take this, we take the substitution, and plug it in for x into equation 2. And yes, I'll write that down as a step. Two. Plug x into equation 2. I'm going to flip my laptop. Hang on. Oh, oops. There we go. So we plug x into equation 2. So here is what we have now. I have 3 times my substitution of 4y minus 17 plus y equal to 1. And now we see that this equation is all in terms of y, which means now we're going to solve for y. I'll put that here. Solve for y. Okay. Distribute the 3. 12y minus 51 plus y equal to 1. And then combine like terms. 12y and y make 13y minus 51 equal to 1. Add the 51 over. And you get 13y equals 52. Okay. Divide by 13. And y is going to equal 4. I think so. 52 divided 13 is 4. So here, y equals 4. Okay. I should have wrote smaller. Oh well, I still got room. Okay. So now we have y, but we still need to solve for x. So what you do to solve for x now is you take the value of y, which is 4, and plug it into the substitution we made for x. You take this value of y and plug it in here. And this will give us x right away. So where can I put that? I'll put it right next to it. Three. Solve for x. So we're using this substitution, x equals 4y minus 17. X equals 4y minus 17. And I'll put that y is equal to 4. And all we have to do is substitute it in. You get x equals 4 times 4 minus 17. And we get that x is 16 minus 17, or x equals negative 1. Okay, and one final step. So remember that the solution is a coordinate pair. It's a point. So we have to state the solution as a point. So my fourth and final step is I say my solution is the point negative 1, 4. There it is. That's it. And of course, how could you check your work? Well, you can take this point, plug it into either equation, and see if it's true. Negative 1 minus 4 times 4, yes, that's negative 1 minus 16, which would give me negative 17 for the first one. If I plug it into the second one, 3 times negative 1 is negative 3, plus 4, negative 3 plus 4 is 1. So our solution checks out. Now he did that all in his head. Yes, I did. Okay. So that is substitution. There is no wrong way about it. If I didn't want to rearrange for x, I could have rearranged for y. So here's the different scenarios, right? I could have rearranged equation 1 in terms of y and plugged it in equation 2 for y. Or, here's the other one. We could have rearranged equation 2 for either x or y and plugged it into equation 1. Like I said, there's no wrong way about it. It's whatever you choose. The one thing you shouldn't do, though, is plug equation 1 into equation 1. That'll get us nowhere. That'll just get a 0 or something like that. We don't want that. So equation 1 must be plugged into equation 2, or the other way around. Equation 2 plugged into equation 1. There you go. Okay. So let's do it again. We have substitution method again for example 2. I'll write small. I'll try my best. Okay. So again, we look, do you want to rearrange equation 1 or do you want to rearrange equation 2? And I'm going to say, let's rearrange equation 1 because this one looks easy. We're going to solve for y on equation 1. So step 1, we're going to say, put equation 1 in terms of y. Or I could just make it easy and say solve equation 1 for y. Ugh, words. All right, so 2x plus y equal to 2. All you have to do is move the 2x over. That's it. Move the 2x over. And we get y equals negative 2x plus 2. And guess what we have? We have a substitution. There you go, right? You have a substitution. And now, since we rearranged equation 1, we now take it and plug it into equation 2 for what variable? Y, right? So we take this sub and we plug it in for this y. That's what we're going to do. So, step. Plug y into equation 2. Okay. So let me see equation 2. Equation 2 is 3x minus parentheses, because now we're plugging in for y, negative 2x plus 2 equal to negative 7. So we have just plugged y into equation 2. And now solve for x. All right, so we're going to distribute that negative, which means you'll get 3x plus 2x minus 2 equal to negative 7. Okay? Put it together. 5x minus 2 equals negative 7. Right, 5x, negative 2. Okay, good. Add the 2 over, and you'll get 5x equals negative 5. And then divide by 5, and x will equal negative 1. Okay? We now have x there you go. We now have x. So now all we have to do is solve for y, right? That's it. Solve for y. And again, the easiest way to do it is take this x value and plug it into this equation that's ready in terms of y. So 3, solve for y. And we'll do that when x is equal to negative 1. Okay. My y is negative 2x plus 2, so I'll write that in. Y equals negative 2x plus 2. And now let's plug the value in. Y equals negative 2 times negative 1 plus 2. And we get y equals 2 plus 2, or y equals 4. Which means we've reached our final step. We say, what's the solution? Which is number 4. And it's the coordinate point. Did we get the same answer as the last one? We did. Coincidence? I don't think so. All right. Negative 1, 4. There's our solution. Okay, and that is substitution method. You rearrange one equation and plug it into the other. That's it. And again, no wrong way about it. If you're wondering, well, how do I know which one to do? How do I know which one to rearrange? Your choice. Look for the easiest one to rearrange. And if it's not easy, well, look for one that looks somewhat easy to rearrange and plug in. So that's how substitution method works. Rearrange one equation, plug it into the other. Okay, so that's substitution. Now we have elimination. Elimination method is a lot faster than substitution. The key word here is eliminate. We want to eliminate a variable. We want to get rid of a variable. And the way we do that is we can multiply either the first equation or the second equation, or we can multiply both equations by a certain number. And when I say certain number, well, we multiply it by a multiple so we can get rid of that variable. Now, when I say multiple, let's look at example 3. Let's say I wanted to get rid of x. I wanted to get rid of x. Well, we see that I have 2x and I have 3x. So in order to get rid of 2 and 3x, we need to make them the same number. So we look for the least common multiple between those numbers. So 2 and 3, we know that their least common multiple is 6, right? The least common multiple is 6. So with that being said, here is how elimination method works. Because when we eliminate, we are going to add the equations together. We must add them. And when we add them, a variable must eliminate. So let's look at this 2x and 3x. And we just saw that their least common multiple is 6. But I have to turn one of these x's negative. If I don't turn it negative, then we'll never eliminate it. So this means that for 2x, I must multiply the whole equation by 3. I'm going to multiply the whole equation by 3. Okay? So let's go ahead and do that. I have room, right? I'll try to write big. There we go. All right. We'll make these into steps as well. Let's say step 1. We're going to call it manipulate. We must manipulate to eliminate. Yeah. Okay, we're going to manipulate. All right. So since 2 and 3 share a common multiple of 6, I'm going to multiply the first equation by 3. So I'm going to say 3 times the equation that's in there, 2x plus y, equal to 3 times 2. So you see we're multiplying both sides of that equation by 3. Okay, and now in order to change this 3 into a 6, I have to multiply it by 2. But remember, one of them has to become negative. So this means I'm going to multiply the second equation by -2. And you'll get 3x minus y equal to -2 times -7. Okay. And then I'm going to rewrite our new equations after manipulating, which means I'm going to distribute the 3 and I'm going to distribute the -2. So I will get 6x plus 3y equal to 6. I will get negative 6 plus 2y equal to positive 14. All right. And now we get our chance to eliminate. When I add these two together, right, we are adding these two together. 6x plus negative 6x gone, canceled, eliminated, right? Eliminate. I guess I should put this here. Eliminate. So we're eliminating. We have manipulated to eliminate, and now we add them to eliminate. All right. And now you have 3y plus 2y, which gives you 5y equal to 6 plus 14, which gives me 20. Now, divide by 5, and y equals 4. Okay, there you go. Now you have y. We have done it by elimination. But now, since we have eliminated, we must solve for x. Well, that's simple enough. All we have to do now is take this value of y and plug it in to an equation of our choosing. It doesn't matter which one you plug it into because you'll get the same answer. So choose the one that looks easier to plug into, and I'm going to choose the one with positive y. I don't want to deal with negatives, so I'll choose the positive y one. I'm going to plug this into equation 1. All right. So let's say 2. Actually, step 2 is eliminate, right? And now 3 is find x, solve for x, whichever. Let's say solve for x. And we know that y equals 4. And I'm going to plug it into equation 1. So I'll write equation 1. Which is 2x plus y equal to 2. And now I'll plug it in. 2x plus 4 equal to 2. Which is still 2x plus 4 equal to 2. If I subtract the 4 over, I get 2x equals negative 2. Divide by 2, and x equals negative 1. Okay, excellent. Which means we can move on to step 4. Solution. Oh, wow. Look at that. Another negative 1, 4. Not all the solutions should be the same. It's funny, though. Okay. And that was elimination. Again, no wrong way about it. Just choose the right multiple. I wanted to show you how to manipulate because this one could have been solved a lot faster because look what we had already in the beginning. We had a positive y and a negative y. Well, if you add those together, they would have canceled each other out already. So if we added these two equations in the beginning, you would have got 5x, because your y's would have canceled, equal to 2 plus negative 7, negative 5, divide by 5, x equals negative 1. Oh, that was so much better, right? But that's fine. I just had to take you how to manipulate, right? If you see something that easy, you go for it. You go for it. I just had to take you down the long road to show you how manipulation works so we can eliminate, okay? All right. Now you're all mad at me. Whatever, yeah. All right, let's do it again. Example 4. All right, look at this. 2x plus 7y equals -9. 3x minus 2y equals -1. All right, so I guess one way to think of this of what do you pick? Well, I see that on the first equation, y is positive. I see on the second equation, y is negative. So the positive and the negative, it's already set up for me. So there's no need to multiply by a negative unless I wanted to get rid of the x's. So I'm going to choose to get rid of y this time, all right? I'm going to choose to get rid of y. And the only reason being is because I have a positive y and a negative y already. So I do not have to multiply by a negative like I did on the other example. All right, which means that before we begin, look at 7 and 2 and think of their least common multiple. 7 and 2 have a least common multiple of 14. So this means that I get to multiply the first equation by 2, and I get to multiply the second equation by 7. All right, so let's put that to work. Step 1, manipulate. Manipulate. All right, so we have the numbers there, so that's what I'm going to do. I'm going to say 2 times the first equation of 2x plus 7y equal to 2 times -9. And then I have 7 times the second equation, 3x minus 2y equal to 7 times -1. Clean it up, distribute the 2, distribute the 7. We get 4x plus 14y equal to -18. Oh, and it's very, very easy to mess up a sign here. So be very, very careful. And then 21x minus 14y equal to -7. Now here comes step 2. Eliminate. We want to eliminate, so we're going to add them together, right? We add them together. And when you add these together, 4x plus 21x is 25x. 14y minus 14y, right? 14y plus a -14y is canceled. Equal to -18 plus a -7, that is a -25. And now divide by 25 and you'll get x equals -1. X equals -1. All right. So now we have x. We just need to solve for y. That's it. Okay. So that's going to be step 3, solve for y. And we solve for y when x equals -1. And again, you get a choice. You can plug this x value into either equation of your choosing, right? And x is negative, so no matter what, that's going to be negative. So let's have fun. I'll plug it into equation 2. Plug it into equation 1 if you want. You'll see that we get the same answer. Okay. So I'm plugging it into equation 2. All right. So equation 2 is 3x minus 2y equal to -1. All right, plug it in. 3 times -1 minus 2y equal to -1. You get -3 minus 2y equals -1. If I add the 3 over, I get -2y equals a +2. And then I divide by -2, and y will equal -1. And finally, we have a different solution than the last 3 same solutions. So, unless I did it completely wrong, but I got it. I know I got it. Yeah. Okay, good. So which means for our solution is the coordinate point -1, -1. And that is elimination. If you hate manipulation because it gives you too much freedom, because this is the only time in math you are allowed to do what you want, as long as your work is correct. Then, if you hate elimination, stick with substitution. Whichever you prefer. No matter what method you choose, you're gonna get the same answer. But elimination is just that much faster. Because it's like thinking on your feet, right? It's like, oh, that common multiple is 6, let's go. Let's get rid of that x. Or that common multiple is 14. Let's get rid of that y. So, all right. Moving on. Okay. So sometimes when we solve a system of equations correctly, we may get 0 equals some non-zero number. So for instance, if you get 0 equals 17, is that a true statement? No, that is not a true statement. So if we get a solution like this, then the answer is no solution, because the system of equations is inconsistent. This means that your lines must be parallel, right? Your lines must be parallel. Okay. And then for the second row, you may end up with 0 equals 0. So you can get, oops, you could get 0 equals 0. Is that a true statement? Yes, that's a true statement. If you end up with 0 equals 0, this means that the system of equations has an infinite amount of solutions. It has infinitely many solutions. This means that the lines, the equations are exactly the same and lie right on top of each other intersecting at every single point. So that's why it's infinitely many solutions. So let's go and try these two examples out and see what we get. Hint, hint, it might be something in the box above. Worth a try though, right? Okay, it lets us practice elimination method because that's what I'm going to use. It's a lot faster. So we start with example 7, and we have 3x minus 2x, 3x minus 6y equals -9, negative 2x plus 4y equals 12. Well, I'm going to do 3 and 2 because their common multiple is 6. If I choose 6y and 4y, their common multiple is 12, which is way bigger than 6. So it's going to be easier to do 3 and 2. All right. So this means that I will multiply the first equation by 2, and I'll multiply the second equation by 3. Okay. So with that being said, if I do it, so for the first one on manipulate, we know how it works now. So I'm just going to have 2 times all of this, 3 times all of that. So I'm going to write the new equations down below. I'm going to save us some time. I figure we should have it by now, right? All right, so my new equations are going to be 6x minus 12y equal to -18. And then down below, -6x plus 12y equal to 36. Now here comes step 2. Eliminate. Whoa. Eliminate. Well, look what happens. 6 plus -6, gone. -12 plus 12, gone. If there's nothing on the left side, what number represents nothing? 0. Equal to -18 plus 36 is a +18. Well, look what we ended up with. 0 equal to 18. Is that a true statement? That is definitely not true. I hope it's not true. I hope 0 doesn't equal 18, which means that this is no solution. Or we can say the system is inconsistent. What did I watch last night? I watched Princess Bride, and now that word stuck in my head. Inconceivable. Inconceivable. and the swords guy goes, I don't think you know that. You use that word, but you don't know what it means. Or I don't think you know what that word actually means. Something like that. It was like 3 in the morning. Okay, so there we get an inconsistent. All right. Now, let's try it again. Elimination method again. All right. Let's see. 5x, 15x, 7y, 21y. All right. Well, we can go smaller. 7 and 21 are bigger than 5 and 15. So let's do 5 and 15. And the least common multiple between 5 and 15 happens to be 15, which means we only have to manipulate one equation, which is something you haven't seen before. We've been manipulating both equations. Sometimes you only have to manipulate one. So that's why elimination method is crazy. You're given all this power to do something, but you're like, no, that can't be right. But it is, right? It is. So we are going to multiply just the top equation by 3. So 1, manipulate. And I'm just going to distribute this 3 to this whole equation over here, and you'll get 15x minus 21y equal to 39. The bottom equation stays the same. Negative 15x plus 21 equals negative 39. Now here comes your favorite part. 2. Eliminate. You're going to eliminate. Okay. Which means that, of course, we are adding, and 15x plus negative 15x, gone. Negative 21 plus 21, gone. What number represents nothing? 0. Over here, 39 plus negative 39, 0. Look at that. Is that a true statement? Does 0 equal 0? That is true. And if we reference the box above, this means we have infinitely many solutions. And this means that the system is consistent. Excellent. Awesome. So if you were to dive in further to this, which we won't because this is business math, it's actually pretty cool because you can say that a variable is free. So like you would have to put it in terms of another one. So say if we solve this equation for y, it would be like y equals 2t plus 1. And since we zero out all the time, this means that no matter what value you pick, you're always going to get a true solution. 0 equals 0. So you have to put it in terms of t. And this means that t can be any number, which means t is free. But like I said, that's not our class. It's just fun to explore. So, whoops. Something to think about. Okay, there you go. So we ran into those issues. We got an inconsistent system, and we got a consistent system with infinitely many solutions. Okay. Last problem. Applications, which we are going to use a system of equations to solve. But first, we're going to have to create the linear equations. We're going to make our own system of equations. So buckle down. This could be not too long, but it's going to use stuff we've learned from 1.1 and 1.2. How to make a linear equation. Remember what you need to make a linear equation. 2 ingredients, slope and a point. So we have to pick this problem apart to see what information it's giving us. All right. So at 53 cents per bushel, the daily supply for wheat is 448 bushels, and the daily demand is 591 bushels. When the price is raised to 88 cents per bushel, the daily supply increases to 518 bushels, and the daily demand decreases to 416 bushels. Assume that the price supply and price demand equations are linear. They are lines, which means we have to create them. So A says find the price supply equation. Okay, well, to find a linear equation, we need a slope and a point, which means they are giving us points in this problem. We just have to pick it apart. Okay, so let's look at the things that say supply. So that's what we're going to look at first. So at 53 cents per bushel, so right now, at 53 cents per bushel, the daily supply for wheat is 448. Guess what? That is our first point. And now when setting up points, y always represents price and x always represents an amount. So 53 cents is my y, daily supply is my x. So they're giving us the first point, which I'll put down. They gave us 448 and 53 cents. Now let's look for the other supply point, which is down here. When the price is raised to 88 cents per bushel, the daily supply, moving around too much. The daily supply increases to 518 bushels. There is our next point. 518 and 88 cents. Guess what? We have 2 points. What can you find between 2 points? That is right, slope. Okay, you can find slope. So that's what we're going to do. There we go. All right, I'm going to say find slope. And remember, label everything. Why not? X1, Y1, X2, Y2. And slope is M equals Y2, which is 0.88 minus Y1, which is 0.53, over X2, which is 518, minus X1, which is 448. All right. Now, 0.88 minus 0.53 is 0.35. That's because okay, 0.35, and 518 minus 448 is 70. And now 0.35 divided 70 gives me a slope of 0.005. There's our slope. And now we must find our equation. And remember, our equation is y minus y1 equal to m times x minus x1. Again, it's good we have everything nice and labeled. We have an x1, we have a y1, plug them in. Y minus y1, which is 0.53, equal to our slope of 0.005 times x minus x1, which is 448. All right. Distribute the 0.005, and we have y minus 0.53 equal to 0.05x minus 448 times 0.005. We get 2.24. All right, almost there. Add that 53 cents over. And we get y equals 0.005x minus 1.71. Okay, so there's the linear equation, but we want to put it in terms of price and supply. So price is y, supply is x. So when I say put it in terms of that, all we have to do is rewrite this as P equals 0.005 Q minus 1.71. This is our price supply. Okay. Ooh, that was price supply. Now we need price demand, which means, again, just pick this apart. We start with the first line, 53 cents per bushel. The daily demand is 5.91. There you go. There's our first point. 5.91 and 0.53. And then the next one is price is raised to 88 cents per bushel. The daily demand is now 416 bushels. So there's our next point, 416 and 0.88. Okay, excellent. All right, so you have 2 points. Now we find the slope between them. Damn. Let me text my neighbor back. Okay. Here's x1, y1, x2, y2. Find our slope. And m equals y2, which is 0.88, minus y1, which is 0.53, over x2, 416, minus x1, 591. Okay, and let's see, I have 0.88 minus 0.53, which is again 0.35, 416 minus 591, negative 175, and 0.35 over negative 175 is a negative 0.002. Okay, last is find the equation. All right, so y minus, we know the formula, y minus y1, 0.53 equal to slope, which is negative 0.002 times x minus x1, which was 591. Okay, distribute y minus negative 0.53 equal to negative 0.002x plus that times 591. Ooh, negative, actually positive, 1.182. And then add the 53 cents. And we'll get y equals negative 0.002x plus 1.71. We'll just round it. 1.71. Okay. Almost got it. Put it in terms of price and quantity. So P equals negative 0.002Q plus 1.71. There's your price demand. Okay. So next one, get in there. Oh, almost there, almost there, almost there. Find the equilibrium price and equilibrium quantity. So to find where the equilibrium price and equilibrium quantity is, that means they both must intersect, right? This means they both must be equal to each other. So all we have to do here is set the price. To find the equilibrium point, all we have to do is take the price supply equation and set it equal to the price demand equation. Well, it's a good thing we have those equations. So my price supply is 0.005Q minus 1.71. Equal to my price demand, what we just made, negative 0.002Q plus 1.71. And all we have to do now is solve for Q. So add the 1.7 over. So let's say and then add this over. So many colors, right? We get 0.007Q equal to 3.42. and then divide by 0.007, and Q is equal to 488. It says round to the nearest cent and nearest bushel. So quantity is bushel, so I get 488.57. So we're going to say 489. So 489 bushels. And now we have Q. All we have to do is now solve for P, which means take 489 and plug it into here or here, and we're going to get around the same exact value. So I'm just going to plug it into the first one. So a little section, I'm going to say find P, and we have P equals 0.005 times Q, which is 489, minus 1.71, right? Is that good? Yep. 0.005 Q minus 1.71. And 0.005 times 489 minus 1.71 is going to be 74 cents. Which means we have found our equilibrium point. Our equilibrium point is 489 and 74 cents. Ooh, okay. There it is. Now the very last one. Graph the two equations in the same coordinate system. Identify the equilibrium point. Supply curve S, demand curve D. All right. I'm going to make this really simple. It doesn't have to be perfect. So our supply function, let's look at it, has a positive slope of 0.005x. So our supply is going to look something like this. Our demand has a negative slope. So it's going to look something like this. And guess what? The point that they intersect at happens to be the equilibrium point. And that point is 489 and 0.74. That's it. Didn't have to be perfect. And that finishes 4.1. Yeehaw. All of that was fun until this very last one, right? But it's honestly, it's going over everything that we have learned so far. How to make a linear equation, how to eliminate a variable, how to solve a system of equations, how to graph, all that good stuff. So this is everything we know. And since it's remote, since it's recorded, of course, it's going to take a lot longer. But there's a good thing. There's a fast forward button on YouTube. All right. That is it. Thank you.